something that if you haven't seen for 3 months, you're going to forget. But you can understand the process of how we came up with them. So for example, to do the inverse cosine parent graph, we first start with the cosine values, and those you do have memorized, so I would just stick with those. And inverse cosine, what quadrants are we stuck to? 1 and 2. So any critical values from 0 to pi, and I'm going to only put ones that have nice numbers, like 0, like pi over 3, pi over 2, 2 pi over 3, and pi. Because the cosine of 0 is 1, cosine of 60 is a half, cosine of pi over 2 is 0, then this is negative a half, and this is negative 1. That will give you the parent graph when you flip the coordinates, right? So in the cosine graph, the y-axis is labeled from negative 1 to 1, but here it's going to be the x-axis labeled negative 1 to 1. I'm just going to do this arrow so that we remember that we're like switching these. And your x coordinates went from 0 to pi. Now they're going to go. Now your y coordinates are going to go from 0 to pi. But we're shifting this up pi over 2. Yes? So rather than going from 0 to pi, I'm going to go from 0 to 3 pi over 2 would make sense. So if I want to go to 3 pi over 2, look at my denominators. Counting by pi over 6 would be most helpful. Question is, 3 pi over 2, if that's as high as I want to go, can I make it to 9 pi over 6? 1, 2, 3, 4, 5, 6, 7, 8, 9? If not, then you could do every half unit is a pi over 6 and you would be fine. So maybe I'll do it that way. You can do whatever way you want. So I'll do 1 pi over 6, 2 pi over 6, 3, 4, 5. So there's my pi. 7 pi over 6, 8 pi over 6, 9 pi over 6. So that's 3 pi over 2. And this one is pi over 2. So we're going to flip the coordinates, and we're also going to shift up pi over 2. Can we do that all at once? And you guys follow? Or would you rather flip around the table of values first and then worry about, well, let's do that. So inverse cosine of x will be 1, 0, 1 half pi over 3, 0 pi over 2, negative a half, 2 pi over 3, negative 1 pi. And then because of the shift up pi over 2, I'm going to add pi over 2 on to all of those y coordinates. So 1 will map to pi over 2. Pi over 3 plus pi over 2. That's 2 pi over 6 plus 3 pi over 6, so that will map to 5 pi over 6. So 1 half and 5 pi over 6. Pi over 2 plus pi over 2 is just pi, so 0 pi. Two pi over 3 plus pi over 2 is going to be 4 pi over 6 plus 3 pi over 6, so 7 pi over 6. And pi plus pi over 2 is 3 pi over 2, so negative 1, 3 pi over 2. Good? So you can memorize and just do your inverse you just aren't really going to memorize the parent graph, I don't think. I don't think it's really practical to do that. Stick on what you do have memorized, and then your concepts that you know, like flipping the x and y coordinate, and you'll get there. Any questions? How about we try this next one on our own? The inverse sine. Raise your hand if you're done. Raise your hand. Stop. Whoa! Let's see where we are. Uh-oh. Oh no. I see what I like. Okay. So this person started with their sine of x. Now, they chose pi over 3. And what's the sine of pi over 3? What's the sine of pi over 3? Krista? Radical 3 over 2. I wouldn't have picked that point then. Just pick the ones that give you nice numbers. So for the cosine curve previously, pi over 3 worked because the cosine of pi over 3 is a half, which is a pretty easy number to deal with. Root 3 over 2 is not a pretty easy number to deal with. So don't pick pi over 3 as you go through your quadrant. Instead, pick pi over 6 because that will give you 1/2. Yes? Now, this person also picked x values between 0 and pi. That was okay for cosine because inverse cosine only has values between 0 and pi. Inverse sine has values between what and what? Negative pi over 2 to positive pi over 2. So this is fine, but these numbers should go from negative pi over 2 and all the way up to 0. So negative pi over 2 and negative pi over 6 would be the second quadrant ones that we want. So negative pi over 2 is negative 1 and negative pi over 6 is negative 1/2. Now you have nice numbers. Now you can flip them and so on. Okay? This person did a good thing. They used the pi over 6 and the negative pi over 6, so they were in the right two quadrants. It looks like they used pi, though, which they shouldn't have. They should be going, remember, on your unit circle between negative pi over 2 and positive pi over 2, so they just needed a negative pi over 2. Okie doke? So, that's what your sine table of values should look like. And then your inverse sine flips all of those. So that's all I did there is I just flipped all of them. And then the transformation is left 1 unit. So which coordinate gets changed when you move left? The x-coordinate. You subtract 1 from all of the x-coordinates. So if you want to rewrite it again, you can, but it's going to be negative 2, negative pi over 2, negative 1.5, negative 1, negative 1/2, and 0. Yes? And so, if you remember from the first day, like your kind of parent graph of inverse sine, has that shape to it, and then it makes sense that it's shifted left 2. See? That was our parent graph on day 1. We just, or not left, did I say left 2? I meant left 1. There's our parent graph, so that's the general shape, and it's just been shifted left a unit. Obviously, my 2 graphs day to day are scaled differently, so it's not a complete match. Your cosine parent graph, inverse cosine parent graph, looked like that. And so, here it is, just shifted up 1. Same general shape. Okay? Here was our tangent parent graph, our inverse tangent parent graph. In our third example here, this is going to be stretched vertically by a factor of negative 3, which is actually stretched and reflected, correct? So let's go to our initial table of values for tangent. And since we're dealing with inverse tangent eventually, which quadrants should we limit this to? First and fourth. Good. So negative pi over 2 all the way up to pi over 2. What tangent values are easy? Meaning they're not radicals. Tangent of what? Pi over 4. So negative pi over 4, 0, positive pi over 4. So this is undefined. This is undefined. Tangent of 0 is 0. Tangent of negative pi over 4 is negative 1. Tangent of pi over 4 is positive 1. Then we're going to go to the inverse tangent and just flip everything. So when our graph is undefined, that means we have a what? Asymptote. So we're going to have an asymptote at a y-coordinate of negative pi over 2 on the inverse tangent graph, and at positive pi over 2. Then, when you take a function and multiply it by negative 3, which coordinate is affected? The y. So you're going to multiply everything by negative 3 and come up with a new value. I shouldn't be using an x. That's foolish. So this first one, it becomes 3 pi over 2. Then we have 3 pi over 4. Then we have 0, negative 3 pi over 4, and negative 3 pi over 2. So we now have asymptotes at y coordinates of 3 pi over 2 and negative 3 pi over 2. And then based on our other denominators, we have a denominator of 4 and a denominator of 2. So we can count by pi's over 4, and that will cover everything. So on our y-axis, we're going to count by pi over 4. And our x-coordinates just go from negative 1 to 1. So I'm going to put an asymptote at y equals 3 pi over 2, which is 6 pi over 4 here. Right? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, and 6. And also at negative 3 pi over 4. And then put my other points in between. So I've got 0, 0, negative 1 and 3 pi over 4, positive 1 and negative 3 pi over 4. So this one's a little bit trickier in the sense that if you just connect those 3 points, they're going to connect linearly. And we should know that this is not in any way a straight line. So when you approach an asymptote, you're supposed to head off towards positive infinity or negative infinity. This is a horizontal asymptote, so it's going to be kind of like that. And down on the bottom, it's going to be kind of like that. And if you look at the curvature of your parent graph from the other day, you can see the reflection, right? And you can see that the horizontal asymptotes are further stretched out because of that vertical stretch. These were at negative pi over 2 and positive pi over 2, and they got stretched by 3, and now they're further apart. Any questions? Yep. If you're just graphing the sine of x, the domain is unlimited. But knowing that we're using the sine of x to get to the inverse sine of x, we want to make sure it's going to be a function still. So in order to make sure that happens, we pick a section of the sine graph. This brings us back to day 1. We pick a section of the sine graph from here to here that passes the horizontal line test. That's the whole reason why sine only goes from negative pi over 2 to pi over 2. Cosine, we pick this section, which is 0 to pi. And then tangent, we pick this cycle because it passes the horizontal line test, which is back to negative pi over 2 to pi over 2 again. So if you think back to why we are limited, I know for the moment we just kind of, I want you to memorize them and moving forward and just know them. But remember back, this is why it all started. So when we inverted it, the inverse will pass the vertical line test, and we can attest to the fact that it does pass the vertical line test. In this one, because we picked this section, the inverse should pass, since this passes the horizontal, the inverse should pass the vertical, and it does. Okay? if this were to ever keep going, it would kind of come back. And that's where the problem would come in. And then tangent, same thing. So all of those pass the vertical line test. All right, flip to the back. Okay, domain and ranges again. So this is more of what we did yesterday, because I do realize it takes a lot of thought and getting used to. What numbers am I allowed to plug in to inverse cosine Cont'd? -1 to 1. So my domain is -1 to 1. And then when I take the cosine of anything that's between -1 and 1, what kind of answers am I going to get? No, I totally missaid that. I could plug in anything from -1 to 1. My inverse cosine is going to get me anything between 0 and pi, right? So then when I take the cosine of something between 0 and pi, I'm always going to get an answer that's what? Anytime you take the cosine of anything that's between 0 and pi, if I take the cosine of any of these angles, my answers are always between what and what? Andrew? Let me do it this way. I'm going to do something different here. I'm going to sketch an inverse cosine parent graph, which looks something like this. This is pi. This is 0. This is -1. This is +1. And then I'm going to do a cosine graph. 0, pi, 2 pi. So when I first am looking for the domain, I'm looking for the domain of inverse cosine, which was the -1 to 1. Did everyone see that visually? When I plug in a -1 to 1 to that piece, I'm always going to get something that's between 0 and pi. Yes? And then when I take the cosine, so we're over to this graph, of something between 0 and pi, what is my answer always going to be between what and what? -1 to 1. Does that help? So here we have a sine graph if we want the visual. Well, first of all, let's see how we do without the visual, and then we'll use the visual to check. What do you think the domain would be, Morgan? When I initially plug into the sine of x, what am I allowed to take the sine of? You don't know, do you? Who thinks they know? Mitch? All real numbers. And then you plug in any real number, you're always going to get something that's between -1 and 1. And if you take the inverse cosine of something that's between -1 and 1, what is your range of the outputs? Who thinks they know? Olivia? 0 to pi. So I'm going to graph a sine curve and an inverse cosine curve, and we'll see if we believe all of that. There's a sine curve. And then inverse cosine. We already have it, but I'll do it again. 1, -1, pi. Okay. So when we initially have it to pick an angle to plug into the sine, A sine curve has a domain of all real numbers, so that's good. We will get an answer that's between 1 and -1, which will be the types of answers that we plug into inverse cosine. So if in inverse cosine we plug in anything between -1 and 1, what are we going to get back? Something between 0 and pi, correct. This is interesting. What kind of x's am I allowed to plug in? Mitch. Anything from -1 to 1. Now the range here is very different. I know the range of this piece individually, and I know the range of this piece individually. The range of inverse cosine is 0 to pi, and the range of inverse sine is -pi/2 to pi/2. But when I do the subtraction of that, I don't really know exactly how they're going to pair. I might not necessarily ever have the 0 subtracting the -pi/2, right? The low end on this one might subtract the high end on that one depending on how your angles work. So I think the only way to do this is sort of just start exploring. If I'm allowed to plug in anything from -1 to 1, I'll start and just do one of them and see what I get. So what is the inverse cosine of -1? The cosine of what angle gives you -1? Cosine of what angle gives you -1? Pi. So that'll be pi minus, and inverse sine of -1, the sine of what angle gives you -1? It would be 3pi/2, except for we have to give an answer between -pi/2 and +pi/2. So what angle is pretty much the same thing as 3pi/2, but in the appropriate range? Pi/2, if you think about your unit circle, pi/2 is up here. 3pi/2 is down here. So what coincides with 3pi/2? That's between -pi/2 and +pi/2. -pi/2. So -pi/2. So I plug in -1, and I get pi minus -pi/2, which gives me 3pi/2. It seems like that would be one of the most extreme cases, because that's the highest inverse cosine would ever be, right? Between 0 and pi. And that's the lowest inverse sine would ever be. And so if you start taking the highest number and subtracting the lowest number, then that's going to probably give you a maximum. Does that make sense? If you don't really put that together, that's fine. We're just going to do more values and see. Plugging in like you're plugging in your sort of your output value. So like if I were to plug in a -√2/2, that's between -1 and 1. What's the inverse cosine? I'm just going to use this space. What's the inverse cosine of -√2/2? Joey? Yes, but cosines have to be between 0 and pi. So what's the pi over 4 angle in between 0 and pi? Who can say now? You know it's always a good sign? Like when people look up to the ceiling. That means they're thinking. And you almost like have to close your eyes and think it through. Cosine, you're limited to quadrants. With cosine, you're limited to quadrants 1 and 2. So which one is going to give you a negative value? Which quadrant, 1 or 2? 2. And what's the pi over 4 angle in the second quadrant, Trista? 3 pi over 4. Minus, we want to do the inverse sine of negative root 2 over 2. And inverse sines are limited to negative pi over 2 to pi over 2. Since it's a negative output, which quadrant are we in, 1 or 4? What's the pi over 4 version in the fourth quadrant? Pi over 4 is over here. We also you go either backwards to negative pi over 2 or forwards to pi over 2. Negative pi over 4. So negative pi over 4. So that's 3 pi over 4 plus pi over 4, which is 4 pi over 4, which is pi. So we're coming down, right? That's higher, and it's coming down. Let's just do 0, because that's easier. What's the inverse cosine of 0? Cosine of what angle will give you 0 between 0 and pi? Andrew? Pi over 2 minus, what's the inverse sine of 0? So the sine of what angle will give you 0 between negative pi over 2 and pi over 2? John? What angle between here and here has a sine of 0? Mm-hmm. So we're still coming down, yes? Let's just jump right all the way to the other end. We said anything between negative 1 and 1. If we plug in 1, what angle between here and here? By the way, this is like the moment I'm talking about, where your head starts to hurt, and a couple of people, 3 to 4 people, like get it, and are the participants, and the rest of the 15 of us check out and just wait for the answer. This is a moment where you either choose to keep trying and be mentally engaged, or you just take a back seat. And this is where we separate the A's from the D's in this chapter. So stay with me. Don't check out if you're feeling lost. Listen over and over and over again and keep trying until it clicks. We're plugging in 1, so the cosine of what angle from here to here equals 1? Anywhere between 0 and pi. Mackenzie. 0 minus, and we want the inverse sine of 1. So what angle is it between negative pi over 2 and pi over 2, where the sine of that angle equals 1? Olivia? Pi over 2. So that gives you something as low as negative pi over 2. And that would be the highest right down to the lowest. So after a lot of pain, the range appears to be negative pi over 2 to 3 pi over 2. Which in hindsight, and this is coincidental, it won't always be this way, In hindsight, is your lowest two values added together gives you the lowest, and your highest two values added together gives you the highest. That's not a rule that I would say is even remotely consistent, but that's just the way it worked out. Okie doke? Wow, that was a lot. This one's easier. Really quickly, because I have 30 seconds. I can plug in anything. So my domain is negative infinity to infinity. And my range is what I'm going to get when I take sine inverse, which is always between what and what. Good. Good thing that was easier, because I didn't want to think all that through again. All right, there's your homework. Have a great weekend.